Hello, everyone. Yeah, thank you for the invitation. And yeah, I'm glad to be here. And I will share with you today like 10 techniques that might help you to speed up your design process and make it much more easier. But really depends on your, SolidWorks level expertise at the moment. But if you're a beginner or intermediate user, I'm sure actually that this will help you in your design process. So yeah, before actually I start sharing this, I just want to say a few things about me. I'm from Croatia. I have a master's degree in mechanical engineering. Also, I'm SolidWorks professional. And yeah, I'm a founder of the Super SolidWorks Accelerator, which is my all-inclusive SolidWorks course. And in this course, you can practically learn everything from zero to the professional level, from part modeling, sketching, surface design, sheet metal design, finite element analysis, practically everything you need to know. As you can see, like I'm not lying, actually, I do have a degree and certificate. And this is some of my work that I was doing as a junior CAD designer in my first company, and some of the freelancing projects that I was doing. Also, you can subscribe to my YouTube channel, where actually I post pretty much like 80% of the lectures from my course. You can find it for free on my YouTube channel. And I have like CAD&Engineering school. Mostly is about SolidWorks. I do have some CATIA and AutoCAD courses as well. So if someone kind of also working on those things, you can also check it out. So if you stay till the end, of this session, what I'm gonna give you free access to my mini course. Okay. So in this mini course, I show how to actually design those 4 elements here. As you can see, nut, positioner, grill, caliper. Okay. So if you stay till the end of this, I'm gonna tell you how you can actually access to my free mini course. Okay. And yeah, I would start with this session, with this presentation. And the first thing I want to show you is the right sketch. Okay. So this is one technique that actually can help you to actually save a lot of time when you do the sketching, right? So for example, I'm gonna give an example here. You can have some kind of a sketch. Like now I'm going to just make some random sketch. It really doesn't matter. So you have this sketch. And now, for example, you have some another plane. So let's just create a plane. And now maybe you have like more planes here, right? And you need, and maybe, okay, this is very simple sketch, but maybe sometimes, it's very complicated sketch that you can have, right? And so you need that complicated sketch on this plane, right? You can use a mirror if you want, of course, but there is a much easier way to actually do this. And this is using the tool Derive Sketch, right? So how to actually do this? So you can go to the Feature Manager design tree. You can select this plane, hold Control and select the sketch, right? So we select the plane where we want this sketch, and we select this sketch, right? And then we go to the Insert, and here we have the right sketch. And automatically, we created sketch 2, which is the right sketch from the sketch 1, right? So this sketch is now on this plane 1, right? And the thing is that we can't change the form of this sketch, of this right sketch, right? I can take this sketch and I can change the position, but I cannot change the form. If I want to change the form of this derived sketch, then I have to change the form of this sketch, right? So I can change the form like this, and automatically the form will also change here on the plane 1, right? And now you can create as many planes as you want, and you can create as many derived sketch if you want, as you want. So this is very simple example, very, very primitive sketch, but just to show you the idea of this. And when you have some complicated sketch and you want to make, you have to make like the similar sketches like on the 10 different planes. So this can really help you to actually save a lot of time using this derived sketch. So this is the first technique that I want to show you, is derived sketch. The second thing I want to show you is the link dimensions. So I'm going to show you know how to actually use the linked dimensions. This is also very pretty much like if you have experience that probably you know. For those when they don't have so much experience, let me show you what I mean. So you can have some kind of a sketch, right? Let's say, let's just give it a very simple sketch. And now, for example, what we want here, we want to put dimensions here, but we want that all dimensions here will be the same, right? And now we can take the smart dimensions and we can go 1, 2, 3, you know, we can do it like manually, and we can put here dimension, for example, 100. And now we want that 100 will be here as well. And the 100 will be here as well. But maybe, you know, in the future, we have to change those dimensions. And maybe you have like 50 different, like 50 same, you know, 50 dimensions that are the same length, right? And now you have to change all of them. And now if you go manually and change manually one after another, that's gonna, you know, take you a lot of time. But what you can do is you can link those dimensions. So when you change one dimension, automatically, simultaneously, all other dimensions will change accordingly, right? So you have this one dimension. You can go here, right click on this dimension, and here we have the link values, right? So you can click here and you can create a name. So I'm going to just put it here A, okay? And now as you can see here, we have this sign. This means it's linked, right? So now I can go here on dimension of this line. So instead of actually putting the number 100 here, 100 millimeters, I can go equal, and here I can go under global variables, okay? Oh, just a second. And here I have this global variable that I created, 100 millimeters, okay? I can select this, I can click OK, and now here I have the sign of the equation, right? That means that this dimension is equal to this dimension, right? And if you go here to the feature manager design tree, you can go here under equations, and you can equation folder, and you can find here your global variable A, okay? And the same thing, I can go here to this dimension, right? I can go here, and I can go here equal, choose a global variable, and click OK, right? And again, here we have the sign that this is equation. That means that this dimension is equal to this dimension here, okay? So for example, now if I change, now if I have to change those dimensions, right? And now I don't have to go manually change each dimension. I can just go here and change this one dimension. I can go to 50, right? And automatically those other two dimensions will change to 50, right? And when you have a lot of dimensions like 20, 30, they're the same length. Like using this linked value, it can save you a lot of time, right? So this is just one way how you can actually save you a lot of time. But now maybe, for example, you have one dimension here, but you want that this dimension, the length here of this line will be, I don't know, 50% longer, right? Or 2 times longer, right? In this case, you have to use equations, okay? So what are we gonna do? Like in the third technique, I'm gonna show you actually more about the global variables and the equations, okay? So let me show you. So let's create one sketch. But before actually we put some dimensions, we're going to go out and I'm going to show you how to actually create global variables and how to actually create dimensions, okay? So you can go here under the tools and go here under equations. So here you can create global variables, okay? So for example, I can go with A and I can say that A will be 100, okay? Then I can put a B here and I can say that B will be A divided by 2, right? Then I can go with C and I can say that C will be A plus B divided by 3, for example, right? And I can go also put a D and I can say this will be A plus C, right? So what we created here, we created global variables and we created equations, right? Because for example, you want to have that, you have like a lot of dimensions, right? And you want that they have a specific relation between each other, right? That you don't want to change, right? You just maybe want to change those global variables, but you don't want to change those relations, right? A divided by 2, A plus B divided by 3, A plus C. You don't want to change those relations, right? But you want to change only those global variables, right? In this way, you have to use those global variables in the equations, right? Because now, for example, I can go to this sketch again, go to the smart dimension. So what I can do here, I can go here with equal, and then I can choose here global variables. So now I can see all global variables here, A, B, C, D. Okay, so I can choose here A. And now here we can see the sign of the equation. Okay, I can go here and I can put here equals B. Okay, and then I can go to this one and I can say equals C. Okay, and so we can see that all of those are equations, right? So now, for example, if I would go here to the tools, okay, I don't have to go to tools, but now, for example, if I want to change those dimensions, I have to go here to the equations. Here I have all my global variables. I can go right click, manage equations, right? And now, for example, I can just change A, right? I can say that A will be now 80. And now you can see how actually this sketch changed, right? Now the measures now are different, but the relations stay the same, right? That's the point of the equations. The relations will always stay the same, unless you change them. You can always also change them, right? But also what you can do here now, you can, for example, go to the features, extrude boss base. And now, for example, here, for the depth, you can also choose global variable, right? You can go equal global variable. Let's go, for example, with D, okay? So you can also choose here a global variable. So like I said, if you want to change it, go just here to the manage equations. You can now change A to 150 and everything will change accordingly. Let's click OK. And now our part completely changed, but all the relations stay the same, right? So this is also very useful tools to use the equations when you have very complicated sketch or you have many dimensions that must have specific relation. And this can save you also a lot of time in your design process. So that's the third technique. The fourth technique I'm going to share with you, that's the last one related to the sketching, is using sketch by multiple features. Okay. So what I'm going to show you here, I'm going to show you how to use a sketch, one sketch, and by multiple features. Okay. So let's go here in the top plane. Something like this. So let's create something like this. Here's something like this. And let's exit. Okay. So this is the one sketch, sketch one. But we're going to use this sketch for the 3-4 features. Okay. So for example, I can go here to the extruded boss. And now I'm going to select this sketch. And now as you can see that a whole contour is selected. But what I can do here, I can go here to the select contours. I can clear this, clear selections, and I can select here the contours I want to use in the boss extrude, right? And now, for example, I want to use only this one, like this. And actually, I'm going to say I want to use as well this one, okay? And I will go here with depth, 30 millimeters. Okay, so now what I want to do here, I want to create here a cylinder with a depth 100 millimeters, but I want to use the same sketch, okay? I want to use the same sketch one, right? So I can go here to extrude boss base, and I can select here the same sketch. Very, very simple, right? And I can go here to the selected contours, clear selections, and I can choose only this sketch here, this one here, and I can put here 100 millimeters. Click OK. Right? And now as you can see, if I open this boss extrude 2, this is the exact same sketch, sketch 1, right? And I have 2 features, and I used only one sketch, sketch 1. I didn't create another sketch, right? I can also go here and use extruded cut, right? I can go here, choose this sketch again, select the contours, clear selections, and I can use this one. I will change here direction, and I will go here with 10, for example, right? And click OK. If I open here, extrude cut, sketch 1, right? So now as you can see, I have 3 features here, but I have only one sketch, sketch 1, right? This can also like save you a lot of time to create another sketch, but also save you a lot of memory, right? If you have a complicated, sketches that you don't have to, use different sketches all the time for different feature. So you can use one sketch, and you can use many features, right? As you can see, you can use here extruded boss base, extruded cut, and you can just the only thing you have to do is just to select the contours of the sketch that you want to use in that specific feature. Okay, so this is also very useful technique that you can also use to speed up your design process, right? To make it much, much easier. And those are the techniques that I want to show you related to sketching. Now I'm going to show you some techniques related to part modeling, and then to assembly, and then to drawing. Okay. So the next technique I want to show you is split line. Okay, how to actually use the split line, how to split the body, and how to actually create 3D sketch on the body and use this, for example, with extruded boss base. So what I'm gonna do here, I'm gonna use this sketch this model. I'm gonna just create a new plane. So I'm gonna put here a new plane. Okay, we can just put 10, doesn't matter really. So we're gonna use this plane. We can also use this one here. I could use this one here, but let's create a sketch here. So what I want to do here, I want to split this cylinder, okay? And in order to do so, I have to create one split line. So I'm going to just create one simple sketch. Like this. And exit. Okay, so I'm going to use now this sketch to split this cylinder, okay? And I can go here to the curves, split line. Type of the split, I'm going to here show you today this projection, okay? And here we have two things that we have to select. The sketch that we have to project. We can select this sketch. And then here we have faces to split. So we're going to have this face. And we can just click OK. Okay, now as we can see, now here we actually split this face on the both side, right? But what I want to show you now is I want to use now, for example, what I want to convert this part to the 3D sketch, and then I want to use this 3D sketch to extrude, okay? So let me show you how you can do this. So basically what you can do is you can go to the sketch. Now we have to choose 3D sketch. You can just select this, and you can go here to convert entities, okay? This is it. And now we have here a 3D sketch, okay? So let's exit this. But before we extrude this 3D sketch, we have to actually choose the direction of the extrusion. And so we're going to create one center line here. So now we can choose, like, you know, what's going to be our position, orientation of our center line will be our direction of the extrusion, okay? So we're going to use this center line as a direction of the extrusion. Like this. And now what we can do here, we can go to the features, extrude boss base. We can select the sketch to extrude. And now here we have to choose direction of extrusion. So we're going to select this center line. So let's go with 50. Now, if you click OK, you're going to get an error because, like, here you have checked merge results, right? Which means that's going to merge those two bodies. We want to unmerge this like this. So that's going to be one body. Okay. So let's click OK. And now here we have this feature. So what is interesting about this feature is that this form of this surface here is the same as form of this cylinder, okay? So we actually extruded this cylinder, right? The shape of this cylinder, right? This is what we extruded. In order to do so, you have to use a split line to split this face, convert into 3D sketch, and then use, you know, boss extrude, right? To get the exact same form here. That's the point, okay? So split line is very useful tool. You can use split line on many different, many different things in many different ways, but this is just one way how you can use a split line to create a 3D sketch that you can extrude or do with him whatever you want to do, right? So those are the things related to the sketching. Now I want to show you a few techniques related to part modeling, okay? And the first one will be feature scope. I don't want to explain what is feature scope because it will be easier if I actually show you this. But before I do so, I will create a part, some simple part. So it's going to be like this. Okay. Now I'm going to go to the linear pattern. Here for the direction, I'm going to choose like this direction and go like this. We're going to go with 5 instances. But first, let's select the bodies. It's going to be this body. 5 instances. Let's just go with much higher distance like this. Let's click OK. So now, for example, maybe you have similar situation like this, right? We have like 5 bodies, yeah. So we have 5 bodies. And now, for example, we have to create a cut on the first body, 4th body, and the 5th body. The same exact cut, okay? So the normal procedure would be, okay, let's create the same sketch here, same sketch here, same sketch here, right? So you have to create 3 sketches, right? You can also use here the right sketch, but there is a quicker way how you can do this. And this is by using the feature scope. So let me show you. So let's go here to the sketch and let's first create this sketch that we want to use for the cut. So we're gonna, so what did I do? Okay. Yeah, let's create here a sketch. For example, something like this. And let's exit. So now we want to use this sketch to create a cut here on the first body, 4th body, and the 5th body. We don't want to create a cut here on the 2nd and the 3rd, right? And we're going to use only one sketch. We're not going to create any other sketch, right? So how to do this? You can go to the features, extrude cut. Let's choose this through all, but we're going to go here down. You have option feature scope, right? Let's unselect here, auto select. And now here what we can do, we can choose the body that this sketch will affect, right? So for example, I'm going to select the first body, 4th body, and the 5th body. And click OK. And now as you can see, now we have the exact same cut using one sketch on this body, and this body, right? So this can save you a lot of time. So you don't have to create the exact same sketch on different bodies. If you want to change this, it's very simple. Just go to edit, right? You can go here to the feature scope, clear selections, and then select body that you want, right? You can select this body and this body. And click OK. And this is it. Now we have a cut on those 2 bodies, right? By using only one sketch, right? So this feature scope is very powerful. As I said, you can find it here in the cut extrude. If you go here at the bottom, you're going to find this feature scope. So you can use this to select body that your sketch will affect, right? That this actually cut extrude will affect, okay? So, so you can use this also in your part modeling. That can save you a lot of time. Yeah, this is the first technique in the part modeling that I wanted to show you. Now the second one that I want to show here is multi-body part. Okay, what is the multi-body part, and how to actually use the multi-body part, right? What are the options you have? What options you have when you actually use the multi-body part? Multi-body part is not assembly, okay? Because you don't have mechanical relations between bodies. But what you can do with multi-body parts, you can save each part separately. You can, for example, change the material on each part, right? So let me show you how this works. So we're going to create one simple sketch. Just a second. So we're going to go to the features. You're gonna put 100 and okay. So what is this? Is a multi-body part, right? So if we go here on the feature manager design tree, if we open this folder, solid bodies, we see that we have 4 bodies, right? And what we can do here, for example, we can go here to this body, right click, we can change the material, right? We can go with aluminum, right? To this one, we can go to this one. We can, for example, change transparency, right? Now this one is transparent. We're going to check this, right? You can isolate, for example, this one, right? So now we isolated this. So what we did now, I'm going to go to back. This, which one did I isolate now? Body display material, search transparency. So why don't I have this? So you can isolate those. You can here's the exit. Yeah, you can change the, you can save them separately. But I want to show you something more complex here. I'm going to create another part here. This part. So let's go to the features. Let's go with 10. Let's click OK. And now, as you can see, if we go to feature manager design tree, we have only one body, right? And the reason why we have only one body, because all of those bodies are merged. If we don't have like one body, we can go here to this feature, edit, and we can uncheck here merge results, okay? So let's click OK. And now immediately we have 5 different bodies, right? And I'm going to show you now how you can actually save each body separately, okay? So before we do so, I'm going to save this as a part. So let's save this. And now if you go here to the folder solid bodies, you can go right click and you can go here to the save bodies. And now you can choose here what bodies you want to save, right? For example, I want to save this body, and automatically here, this body is checked, right? And I want to save this body here, and automatically also this body is saved. So before I click OK, just uncheck here, consume CAD bodies, okay? Let's click OK. Now those bodies will be also saved separately, okay? So if I go to my desktop, here you can see this is the part, and this is body 1 and the body 2 that we saved, right, separately. And this is not assembly, this is multi-body part. So this is the, just a second, let me open this. Yeah, so this is like the one option that you have in multi-body part. Like not only that you can like work with body separated, like change the material, you know, isolate, change transparency, you can also save them separately. But here's the one thing that I want to show you. Now, for example, if I go here and I create a sketch here, I'm going to create one cut here. Features, extrude cut. Like this. Let's click OK. Okay, I can save this. And now, if, for example, if I go to this part that we saved separately, so I can go to the window, let me see. This cut is not here, as you can see, right? So this cut is not here. And if you want to have this cut here, right, everything what you do in the part, main part file, if you want that this affect other parts that we saved separately, then what you have to do here, you have to go to the main part. And now here on the feature manager design tree, you can see these save bodies, right? And you can see this cut extrude. This cut extrude comes after save bodies. And that's why we cannot see this cut in this separate part file. So what we have to do, we have to take this and put it here before the save bodies, right? Now this cut extrude comes before the save bodies. And now, if I go here again, I will now have this cut in this part file, right? So those are some of the techniques that you can use with the parts, like by using the multi-body part, right? You can save separately. You can then make changes in the main part, and those changes will affect other parts separately. Sort of like an assembly, right? This way also assembly works, but this is not assembly because there are not mechanical, relations between those bodies. But yeah, like using multi-body parts, right? You can do a lot of things. You can do a lot of things, for example, here in the main part that will make changes also simultaneously in other parts, right? Or you can just change colors, material, you can change other things, specification about, different parts of this body. And this can also save you a lot of time without using, for example, assembly if there are no mechanical relations between those parts, okay? So yeah, this is multi-body part. The next one that I want to show you is in context feature. So now I want to go to the assembly. Okay. Okay, we're gonna also close those one. Now let's show some techniques related to the assembly. Oh no, actually, I have to open my file. I don't need this. Open this one. So what do I have here? I have two parts, okay? And what I want to do now, I want to actually make some relation between those two parts. So I want to put this part here, right in the center of this part here. That's the first thing I want to do. The second thing I want to do here, I want to make this cut the exact same as this cut. And I want to make sure then whenever I change this cut, the dimension of this cut, that this cut here will also change simultaneously. And in order to do so, I have to create in context feature. I have to create external reference, okay, between this part and this cut here, okay? But first, let's go here to the mate. Yeah, let's go here to the advanced mates and let's choose here profile center. This is the fastest way to actually put this one in the center, like this. Okay, so that's the first thing that we want to do. The second thing that we want to do, we want to go here to the part 2, okay? We want to go here to the boss extrude to this sketch. And we want to go with edit sketch. And as you can see, like automatically those parts become, transparent. So what we want to do here, we want to make sure that this cut here, this sketch here, and this edge here are actually in relation. And we're gonna just put a relations between those two lines, collinear, make collinear, and that's it. Okay. So let's exit. And now we can see here that those two cuts are exactly the same, right? But if we go here to the feature manager design tree, here under sketch 1 that we changed, we see this arrow, right? So, and also here we have this arrow here in the part 1, okay? We can see this arrow also here. That means that there is external reference, right, between those two parts. That means, for example, if I go here to the cut extrude to this sketch, and I change this sketch, for example, I change dimensions of this sketch, and I go out, automatically, those changes will affect also the part 2, because there is external reference, right, between those two parts. As you can see, right, these two arrows actually show, this arrow actually show there is actually external reference, right? And now if I go here on the sketch one and right click, I can go here and list all the external reference. So I have here one external reference that I created between edge of the part one and the part two. Okay, the sketch, this specific line, the sketch of the part two and the edge of the part one, right? And if I have this external reference, no matter what changes I will do here in the part one regarding this cut, simultaneously, automatically, this change will be applied in the part two, okay? So this is also a really useful tool that you can use in the assembly when you want to make sure when you make a change in one part, that those changes will be applied on the second, third part. In this way, you can create external reference, this in-context feature, okay? So this is one useful technique that you can use in the assembly. Yeah, now I want to show you one other thing in the assembly, and this is the top-down assembly, right? So pretty much if you have some experience in SolidWorks, you pretty much know how to create a normal assembly, right? You create a part one, you create a part two, part three, and then you go to the assembly file, and then you actually put those parts in the assembly, and you actually kind of define connections, right? Relations. But also there is the fastest way how you can actually create this. You can go directly to the assembly, right? And you can, in the assembly, create the parts and those relations. And then you can save this assembly and those parts separately, okay? And this is a little bit fastest way, and this is the top-down assembly. Completely opposite way to actually create the assembly. So I'm gonna go here to the assembly file again. So I will not insert any part, okay? So I will actually go out of this. What I will do here, I will go here with new part, okay? But now as you can see, I don't have any features here. I can use a sketch, but I don't have any features here, right? So in order to get those features, so we can actually create some part in the assembly file, right? I have to click here and then click here. And now as you can see, here we have option edit component. So you can click on edit component and automatically here we have the features, okay? So first let's go to the sketch. Let's go to the top plane. Let's go with this part. Let's create something like this. Let's put here this dimension just to make sure we know what is the dimension. So let's go with 60. Actually, we don't also need to know what is this dimension, but okay. Yeah, what we have to do now. Features, I have to extrude this. Like this. And let's click OK. So yeah, this is our first part that we created in the assembly, okay? So this is our part number one. Now we want to create the cylinder that goes through this hole, okay? So we're going to create a second part. So we're going to go here, new part again. So now here we have the new part, okay? Again, we have to click here, go to edit component. Let's go here with sketch. We're going to also use here top plane. And what we're going to use convert entities. So we're going to select this edge and convert this, okay? So we're going to go to the features, extrude boss base. So let's go here with 100. And let's exit this. And now as you can see, we have two parts, right? And those two parts we created in the assembly, right? Not in a part file. This is assembly file. But if you try to move this part, it just doesn't work. And the reason why we can actually move them, because if you go here to the feature manager design tree, you can see here F, right? In the part 1 and part 2. This means fixed. We cannot move them. So what we can do, we can go, for example, to part 2, right click, and we can go here with float, right? And now what we can do, we can now move this part in the space, right? So what we want to do now, we want to make sure that this part actually fits this hole and that we can move this part through this hole, right? So we can go here to the mate. So let's select this cylinder, let's select this face, let's click OK. And now as you can see, we can move this part through this hole, right? And we created assembly, and we create those two parts, but in an assembly file, right? That's the point of it, right? We didn't create this part separately and then this part separately, and then insert them into the assembly file. And this is called top-down assembly process, okay? So what we can do now, we can also now go and we can save this, right? Save all. No, here, if you want to rebuild it or not, save document, doesn't matter really. So we're gonna go here, yeah, to the desktop. And now here we have the question. This assembly contains unsaved virtual components which must be saved. So you can save them internally inside the assembly, or you can save them externally. So what you can do here, you can go save externally and click OK. Okay. So what you can see now that we have our main assembly, and we have those two parts that we saved separately, right? But we didn't create them in the part file, right? That's the point of that's the actual idea of the top-down assembly, right? This can also save you a lot of time, so you don't have to create parts separately and then insert them into the assembly file, but you can use this top-down assembly, okay? So yeah, this is regarding assembly. And we have the last technique, and this is the relative view. This is related to the sketching. So let me show you this. So I'm going to open this file. So, sometimes when you're going to create the drawings and you will have to create the orthographic views, sometimes the shape, like the orthographic views, right? The front view will be very weird position, right? In the position on very kind of a strange way. And then you probably don't want to have this position. You want to change actually the orientation, right? Of the front view, right? We want to have a different orthographic view, like from different angle, right? In order to do so, you have to use relative view. So for example, let's go here to the model. We're going to insert this model. And here we have we can choose here front view. This is orthographic view. And now as you can see, this is very weird part, like weird orientation. It's very, very, I would say, unusual, right? And this is not something that we want to have, right? But we can fix this. We can go with different orientation. And in order to do so, to choose like a different front view of this part, we have to use the tool that's a very useful tool in the drawing, and that's like relative view tool. You can find it here. If you don't find it here, you can go here to the search, and you can go here with relative, and then you can choose here relative view. Okay, so the easiest way to actually work with this tool, you just go here to the relative view. Okay, and then what you have to do here, you have to select this orientation. Okay, and what's going to happen automatically, the SolidWorks will switch us to the part file, right? So because as you see, this is the view that I choose just to make a presentation of the relative view tool. But now, for example, we want to have a different front view, different orientation. So if we go here on the left side, we have here first orientation and the second orientation. And for the first orientation, we can choose, for example, front view, right view, top view, back, left, bottom, right? And for the second orientation, we can go right, top, left, bottom, right? So for the front view, I want to choose this face, right? And here I'm going to choose the bottom, and I will choose this, and I can just click OK. And as you can see, automatically, I have here completely different orientation, right? This is orientation that actually I defined. Okay, so this is the one way, right, how you can actually fix this orientation when you actually creating the orthographic views, right? So if you have some kind of a part and you know, and you get like some weird awkward view, then you can use here relative view tool to actually get the orientation that you want, right? You can just pick the orientation that you want. Very, very simple. Yeah, and this is it. Those are the 10 techniques. Maybe some of you were familiar with them because, like, I don't know how many, you know, I don't know each one of you personally, so I don't know what is your SolidWorks level knowledge. But like those techniques can definitely help you. Even if you're a beginner, just start using SolidWorks, or you have experience with SolidWorks, those techniques can help you to speed up your design process, okay?